previous lecture, we looked at the calorimeter and we saw there is a sample, but there is also a reference. And the reference, which is identical to the sample, should be identical to the sample in all respects, except it shouldn't produce any heat. So it should be an inert reference. And the use of the reference is that there are always disturbances coming into this thermostated environment, and they will influence the sample and the reference in a similar way, the same time, similar magnitude, and we actually measure the signal from the sample minus the signal from the reference. So if the same things takes place in the sample and the reference, it will be removed by this subtraction. And the reference is essential. If we don't have a reference, a single calorimeter, it won't work well. So we need to have this twin design. Now, the question is, how do you choose your reference? How do you choose what to put in the reference ampule? And the rule is that it should have the same heat capacity as the sample. Maybe heat thermal conductivity has a minor influence also, but you can interpret that the demand as that it's heat capacity that should be the same in the reference and the sample. And the sample, of course, that is the sample you are measuring on. It contains whatever you like to put into it. The reference should be as simple as possible because it shouldn't produce any heat. And the preferred materials are water, glass beads, quartz, stainless steel, simple materials. Never use an old sample of, for example, hydrated cement paste or something, because that's a complex sample. It contains water, and if you, for example, take it out and put it back again, you will have changed the temperature, and the water may start to move, be absorbed and desorbed inside the sample. That produces heat. So always use simple things like pure water, glass beads, stainless steel, quartz. No complex material systems here. In some cases, it's easy to choose a reference, and I believe the easiest case is when you work with aqueous systems. That is when it's mainly water. It could be bacteria growing in an aqueous solution with nutrients, or it could be a chemical reaction in an aqueous solution. The aqueous solution is usually very dilute, and it contains mainly water. Then we use the same mass of water in the sample, in the reference. So we have a sample with an aqueous solution with a reaction, and we use the same mass of pure water in the reference. That's an easy way to choose a reference, or an easy case. In other cases, it's more complex. One complex case is a cement hydration. Then you have cement and water, and maybe you have sand. So you mix different components to make a sample, and then you have to figure out how to make a reference with the same heat capacity. And then you need to know the heat capacities of water and sand, etc., and do a simple calculation. I will come back to that in another lecture, but that's it's a more difficult case, but still important. Still important to do the calculation and choose a good reference, because choosing a good reference, balancing the calorimeter thermally, is probably the most important step in doing good calorimetry. It's at least step number one, because if you don't do that, you will get more noise, and you may not be able to even evaluate your measurement. So a good reference is essential for good isothermal calorimetry. So in the later lecture, I will discuss more in detail how you choose a reference.